Hey guys, today I'm gonna be working on number 1400, which is construct K Palindrome Strings. So let's read the description. Given a string S and an integer K, return true if you can use all the characters in S to construct non-empty K palindrome strings, or false otherwise. So a palindrome string is basically a string that can be read the same forward and backward. So let's say example 1, we have Annabelle and K equal 2. And the output is true. And here they tell you you can construct two palindromes using all characters in S. Some possible combinations are Anna plus ELBLE, ANBNA plus LE, ANEL, LENA plus B. So basically in this number, they want to check if I've given you K equal 2, then from this, you need to be constructing two palindromes using all the characters. And if you can, just return true. If you can't, return false. So let's see here. LeetCode, K equal 3. It is impossible to construct three palindromes using all the characters of S. True, K equal 4. And the output is true. The only possible solution is to put each character in a separate string. So each character is one palindrome, and that's 4 palindromes, and then it's true. So now let's try and visualize this. And if we check here, we can see, let's say in this one here, we're having example 1, Annabelle, K equal 2. So basically in this number, we need to create a map to check the frequency of each character. And why do we create a map? Because a palindrome, if we have all even frequency of characters, then for sure it is a palindrome. And we can have one odd character inside these even number of characters. So let's see this example. If we here create a frequency map, we can see we have two characters of A, two of N, one of B, two of E, and two of L. And now if I check here, I can see that A and B and A, this can be one palindrome. Why? Because in this case here, we're having A, it's the same, N, it's the same, B is the odd one. So as I said, in a palindrome, all of the left and the right can be even, but only the one in the middle can be odd. Another one is, let's say, this one here, which ANEL, then also LENA. So this here, it's read the same as this, and here all the characters are even. So, and also if we check here, we're having 1, 2, 3, 4. So we're having 4 characters that are even and one character that is odd. The frequency of this character is odd. So if we check here, we can put all the evens in one string, and the odd frequency, we put it alone. Now if we count here, we are having 3, 6, 7, 8, 9. We have 9 characters. If we do here 9 minus 1, we would have 8, and 8 characters, that would be one palindrome. So these 8 would be one palindrome, this here would be a palindrome on its own, and now we are having K equal 2. Now if we check, let's say this example here, we're having Y, 7 times is the frequency of Y, 6 times is the frequency of Z. And they also want 2 palindromes from this whole thing. So we have in total 13 characters. If now I use 6 from Z and 6 from Y, I can create one palindrome. Then I can use the one that's left as a palindrome on its own. Then I can have 2 palindromes. So as we understand so far, is that a palindrome is a character. It's a string that can be read the same from the backward and the forward. And if you have even number of frequency of characters, then they can make up to one palindrome, and we can put one odd in the middle, or it can be alone. So that's how you can think about it, that okay, we have 8 even, 1 odd, these are 2 palindromes. We have 12 even, they make 1 palindrome, 1 odd, that's 2 palindromes. Now if you check here, we don't even have any even frequency, so we can't create an only even frequency palindrome. And they want here 3 palindromes. And we're having, let's say this is 1 palindrome, this is 1 palindrome, this is 1 palindrome, these are 3. But then we have this 4 palindrome, 5 palindrome, and this here, the whole thing can be 6 palindrome. That's why this is false. Now if you check here, example 4, true, each character can be a palindrome, and then you just return it. So as we saw in these examples, first we need to create a frequency map to count how many times each character is appearing. Then we need to loop again in that frequency map, and we need to check how many odd characters we have. And we do this, of course, by checking the value of each property in this map. So if we have this, we would have, in this example, we would have odd characters equal to 1. And then we know that if odd characters are 1, and if the odd characters are less than or equal to k, then this would be a palindrome. This would be an output true. So let's try and check this in the code. If we go to the code here, let's try and write this. So as we said, first we need to get the frequency. We do this by doing frequency map equal empty for I in range length of s, frequency underscore map s I equal frequency underscore map dot get si 0 plus 1. Here we build the map as we just saw in the other in the drawing. Now, as we said, we need to be creative. We need to check how many odd characters we have. So let's say in the first number here we build the map, we would have a is 2, n is 2, then b is 1, e is 2, and l is 2 also. So this would be our frequency map. And as we said, we can have the following. We can have this one as a combination. And now what we can do is that we need to count how many odd characters we have. So if I come here and I put odd chars equals 0, then I just loop for key value and frequency underscore map dot items. Now I just check simply if value modulo 2 is not equal to 0, then odd underscore chars plus equal to 1. Now I counted here that I have 1 odd character. And now basically at the end I just check if odd underscore chars is less than or equal to k, and k is less than or equal to lns, then return true, else return false. So in this case here, this would be returning true because the odd characters are less than or equal to k. So if we have here 1 odd character, we know that from the others we can create an even string, which would be palindrome. By default, we don't have to count this. And then we would return true. Now, if we check, let's say, LeetCode, it would be L is 1, E is 3, T is 1, C is 1, O is 1, D is 1, and that's it. and then they want K equal 3. Now we would have this frequency map. And if I'm looping here in this map here, and I check how many odd characters or odd frequency I would have here 1, 2, 3, 4, 5, 6. So here odd underscore trials would be 6. That means that I can create 6 palindromes from this one here. And 6 would be greater than K, which is 3, then it would return false. Here again, we would have one palindrome that would be odd, and the others we don't care about because they would all make one palindrome, and then if this is less than K, we would return true. Same thing in this one here. We're having T1, R1, U1, and E1, and K equal to 4. We're having odd characters equal 4. And since it is less than or equal to K, then we can satisfy the condition and we can return true. So, and then now we can run this to check. As you can see, all the cases are working. Now we submit. And it's working. So basically, what we do here in a short summary, we first count the frequency map. Then after that, we don't care about the even frequency because we know if we combine all of these even characters, we're having one palindrome. So we forget about the even frequency. We just focus on the odd because that would be our problem. Then if we have odd frequency less than equal to K, we just return true. If it's gonna be more than K, then we know it's not gonna be able to do 3 palindrome. In this case, it will do 6 palindrome, and then we return false. And that's it, guys. I hope you understood this solution, and I hope you understood the explanation, and let me know in the comments if you have any questions, and I will try to help you further. And see you in the next video.